Hey everyone, let's do our first guided practice. Note that I've got Desmos open because the instructions say to use a table to find the limit if it exists, and look at the graph to confirm. So what that means is we're going to do the same thing that we did in the previous lecture. So we're going to enter in, sometimes you need to click it a little bit. Hold on one sec, a little bit of technical difficulties here. F of x is going to equal, let's see, we're going to have 3x divided by 2x minus 1. All right? And what we can do is we're interested in seeing what happens as x approaches 2. So let's look at a couple of values a little bit less than 2. All right? Looks like they're getting pretty close to 2. Right? And if we kind of do that, we see, oh, okay. Looks like we're getting pretty close to 2, right? So we can kind of just enter this in, right? And I think something along the lines of for x, f of x, looking at x equals 1.999, f of x equals 2.0003, x equals 2.001, we have 1.9997, right? If we do this even more, right, if we exaggerate this even more, right, maybe I could even like move this down a little bit. I'll maybe move this up a little bit here, move this up a little bit here. We've got and then, right, and if we did 2.0001, right, well, sure enough, we get, right, 1.9997, right? So we should say the limit as x approaches 2 of 3x over 2x minus 1 equals 2, just based on the strong evidence. Again, we're not proving anything, but it does look like that, right? Looks like something funky is happening maybe at 1/2, right? Maybe you can see why. But at 2, it looks like things are fine. And again, certainly the graph seems to suggest that we're fine. Looking at number 2. Let's see. We've got limit as x approaches 0 of another function, okay? So let's set up our chart here, right? Maybe we'll pick some values that are close to 0, right? We'll do 0.01, 0.001, and then maybe we'll do, actually, maybe we'll just do the negatives first, and then maybe we'll do 0.01, 0.001, etc., right? So let's see, if we do that, we go back into Desmos. Maybe I'll leave that other one and I'll call this f of x equals all right, so we have that. Oh, weird looking function there. All right. Well, anyway, if we just put in f of negative 0.01, why is it not liking that? Oh, I guess it's not liking that. I guess we have to call this g of x. Okay, anyway. Call it g. Oh, well, that's interesting. Okay. Looks like we can get 32 and change. Okay. What if we did that? Oh, that's interesting. Meanwhile, what if we got rid of the negative sign? Well, that's interesting. We have negative 33.78 And then if we said, what if we got closer to 0? Well, look, that's a negative, by the way. Stuff is going a little haywire, right? And maybe you can see why, right? We're dividing by 0. Weird stuff seems to happen when we divide by 0. So it looks like we're saying this limit as x approaches 0 of x plus 1 over x squared minus 3x equals, or I guess I should say, does not exist. Right? And the reason is that the limit as x approaches 0 from the left equals infinity. Maybe I'll move this down a little bit. Limit as x approaches 0 from the right equals negative infinity. And so that means the double-sided limit does not exist, right? So as for this last one, right, well, for that one, maybe I'll just let you try that one.